Hello everyone, welcome to my channel. Please, if this is your first time viewing, consider to subscribe to this channel so that another exciting video will notify. Let's solve this question together. Now look at what we are given. We are given that 2 raised to the power of x plus s equals to 5. We are asked to find the value of x. Wow, this question is as simple as ABCD if you understand what you are going to do here. Now look at what you are going to do. Please pay attention to this video. Now we are given that 2 raised to the power of s plus s equals to what? 5. Wow, this is amazing. Now our first step, what you're going to do is to subtract x from both sides. That's our first step. Okay, now let's do that quickly. So now see that this now be what? 2 raised to the power of x equals to what? 5. Okay, minus what? X, because we subtracted x from what? Both sides. Now our second step, what you're going to do is to divide both sides by 2 raised to the power of x. That's our second step. So if we divide here by 2 raised to the power of x, okay, and also divide all of this by 2 raised to the power of what? X. Now 2 raised to the power of x divided by 2 raised to the power of x will give us what? 1 equals to what? Now look at one of the interesting things we are going to do. That's why when you are working with the law of indices, it's very simple and helpful when solving problems like this. So you can also do something here that if you are not wrong, if you decide to write this as what? 5 minus x multiplied by 2 raised to the power of minus x. We are not wrong, my brothers and sisters, if you really obey one of the properties of indices. Okay, because if we remove this, it will now become what? This will be equals to 2 raised to the power of minus s equals to 1 minus s equals to what? Equals to 1 over what? S 2 raised to the power of s, and 1 times all this will still give us all this divided by same denominator. You can see how simple it is. So let me remove this from here. Now what you are going to do here, look at what you are going to do. Now you can look this problem very well. We are having 1 equals to 5 minus x multiplied by 2 raised to the power of x. Now what are we going to do here? Now you'll be wondering that what are we going to do? What are we going to do? What are we going to do? Wow, there's no solution again. There's nothing I can do to here. There's nothing I can do here. There's nothing I can do here. Now I want to tell you that there's something you can do here. There's something you can do which is very what? Simple and interesting. Now look at this problem very well. We're having that 1 is equals to 5 minus x multiplied by 2 raised to the power minus x. Now look at what you're going to do. Very simple and interesting. Pay attention to this video and look at what you're going to do. Now we are having that 5 minus x multiplied by 2 raised to the power minus x, and here 1 is equals to this. So let's change it. So you can write that this is what? 5 minus s multiplied by 2 raised to the power minus x equals to what? 1. There's nothing change. I just exchange. I exchange it. I take this. Let me say I just take this one. I just change the sign because it's the same thing. Nothing change. You can see 1 was positive, 1 is positive. Nothing change. Now look at what I'm going to do. Now what I'm going to do, I'm going to multiply both sides by 2 raised to the power of 5. Now I'll explain why. The reason why I'm going to multiply both sides, this is x. Sorry for this. This is x. Okay. Okay, this is x. Okay, this is x. Now I'm going to multiply both sides by what? 2 raised to the power of 5. The reason why I multiply both sides by 2 raised to the power of 5. You can see that here the coefficient of 2 raised to the power minus x is 5 minus x, right? Now the reason why I multiply both sides by 2 raised to the power of x is because the base here is 2, right? Now if I multiply both sides by 2 raised to the power of 5, that means I will have what is here as the exponent here. Okay, because if I take a single base and add the exponent, I'm going to have 5 minus x. That's the reason why I'm adding what? I'm multiplying what? Both sides by what? 5. So now multiply what? Multiply what? Multiply both sides. Both sides by what? By 5 raised to the power of 2. Okay. Now multiply both sides by what? 5 raised to the power of what? 5 raised to the power of 2. Okay, let's do that quickly. That means 5 minus what? X. Okay, multiplied by 2 raised to the power of minus s multiplied by 2 raised to the power of 5 is equals to 1 multiplied by 2 raised to the power of what? 5. Wow, this is amazing. The only thing we did here is to multiply both sides by 2 raised to the power of 5, and I've explained the reason why we are multiplying both sides by 2 raised to the power of 5 is because the coefficient of 2 raised to the power minus s is 5 minus x. 2 raised to the power minus s is 5 minus x, right? The coefficient of 2 raised to the power minus s is 5 minus x. And again, since the coefficient of 2 raised to the power minus s is 5 minus x, now look at the power here is minus x, right? Now, and here we are having 5 minus x. So if you multiply both sides by 2 raised to the power of 5, that means we are going to have the same power. The power will be equal to the coefficient of this 2 raised to the power minus x as 5 minus x. Because if from here, if you take a single base and add the exponent, you're going to have 5 minus x. This is the reason why you're multiplying both sides by 2 raised to the power of 5. Okay, because since the base here is 2 and the base here is 2, so 2 is here, right? The reason why we use 2 is because so I can add the exponent. Okay, this is interesting. Now see that 5 minus s multiplied by 2 raised to the power of what? From here, let's take a single base and add the exponent. So this time become what? Minus s plus what? X. Obey one of the properties of indices, right? And this will be equals to 1 times this will give us what? 2 raised to the power of what? 2 raised to the power of 5, because 1 times anything is send that value. Okay, now consider minus, we can also write minus x plus 5 as what? This now become what? 5 minus s multiplied by 2 raised to the power of what? 5 minus what? S equals to what? 30 what? 2, because 2 raised to the power of 5 is what? 32. Now this is what I was looking for. Now observe very clearly that 5 minus s is here and 5 minus s is here. That is what we are looking for. That's the reason why we multiply both sides by 2 raised to the power of what? 5. Is it not interesting? Very simple. Now look at what you're going to do. Now I want you to understand that that s is equals to e raised to the power of what? Ln s. This is one of the properties of what? Logarithm, or this is when we say natural logarithm. It's very, very simple and helpful when solving problems. Okay, note that s is equals to e raised to the power of ln s. This is very helpful and interesting. We're going to apply here. Now, do you know that we are not wrong by obeying this rule or this law? That from here we can also write it as what? 5. Okay, 5. Let me take it up a bit. 5. Okay, minus x multiplied by 2 raised to the power of what? Now in place of this, look at what you're going to do. We're going to write what? Ln what? Ln 2, right? Okay, sorry. That means look at e, so then you become what? E raised to the power of what? E raised to the power of what? Ln 2. E raised to the power of 2 ln what? Sorry. Raised to the power of ln what? Ln 2 raised to the power of 5 minus x. Okay, now all this equals to what? 32. Now look at what you have done. You are not wrong, because that means if we simplify all this, if you're watching my videos I've done on this channel, I've told you guys how I prove that s is equals to e raised to the power ln s. And remember that one of the tricks about this is that natural logarithm are always in what? Base e. Okay, now s is equals to e raised to the power ln x, so the outcome is just x. So that means e raised to the power of ln 2 raised to the power of 5 minus s, it will just give us what? 2 raised to the power of 5 minus x. Okay, very simple and interesting. Now let's also obey one of the properties of logarithm, that you can also obey something, one of the properties here, that is going to become what? 5 minus s multiplied by e raised to the power of what? Now this will come, this will now, 5 minus s will go down. Okay, so multiply the ln, it's become what? 5 minus x ln what? Ln 2. Okay, equals to what? 30 what? 2. Now this is beautiful. Now you can still observe something here, that there's something change. Okay, you can still observe something. Now here we are having 5 minus s multiplied by e raised to the power of 5 minus l ln 2, and here we are now having ln 2. Why are we concerned? Because I know you'll be wondering, Sagas, why are you always concerned about if this did not have, I have to add it to this, or I have to add it to this? Reason why I always concerned is because I'm looking for a way to apply what? Lambda W what? Function. Remember that the lambda W function, of s multiplied by e raised to the power of s is always what? Equals to what? X. Now let's see, or let's assume, or let's check that this e you are seeing here is this e you are seeing. Okay, and this s you are seeing is all this thing you are seeing, which is the exponents, right? And but here is not the same thing as, because the x here and here must be the same. So if they must be the same, that means we have to multiply both sides by ln 2. Can you see how simple it is? So let's multiply this by ln 2. So if we multiply this by ln 2, we want to have that this is into 5 minus s multiplied by ln what? Ln 2. Okay, multiplied by e raised to the power what? 5 minus s multiplied by ln 2 equals to 32 multiplied by what? Ln what? 2. Wow, this is interesting. From here I can take the lambda W function of both sides. That means the lambda W function of 5 minus s ln 2, okay, multiplied by e raised to the power what? 5 minus s link 2, okay, is equals to the Lambda W function into of what 32 link what 2. Wow, this is beautiful. Now you now see that from this, the definition of this, that Lambda W function of s multiplied by e raised to power s equals to s. That means the Lambda W function of 5 minus s link 2 multiplied by e raised to power 5 minus s link 2 just give us what? 5 minus s link 2. Can you see how simple it is? So the outcome of this is just what? It's just 5 minus s what? Link 2, right? Link 2, okay, equals to the Lambda W function of what? 32 link 2. Wow, this is amazing. So what are we going to do here? What we are going to do again is to divide both sides by what? By link 2. So that I can remove this link 2 from here. Remember, our target is to find x. So if we divide here by link 2, okay, also divide here of this by what? Link 2. Okay, this link 2 we can also add this. So now see that 5 minus s is equals to what? The Lambda W function of what? 32 link 2, okay, divided by what? Link 2. I know some people watching this video will be thinking that, Sagas, why can't you just cancel out this link 2 from here? No, don't try it. Remember that this 32 is multiplying this link 2, right? And you have to, before you do that, you have to take the Lambda W function of 32 link 2 before you can divide by link 2. So don't go and cancel it, because people say, why not just cancel it from here? No, don't do it. First of all, take the Lambda W function of this divided by what? Link 2. Okay, now from here let's subtract 5 from both sides. So now I'm going to add that this is minus s equals to what? Lambda W function into 32 link 2, okay, minus what? Minus 5, because we subtract 5 from both sides, divided by what? Link 2. Now we have to multiply both sides by what? By minus 1. So that I can remove, because the coefficient of x here is minus 1, so we have to multiply both sides by minus 1 so that s can be unity. So if we do that, we're going to add that s will be equals to minus 1 into the Lambda W function of what? 32 link 2, okay, minus 5, okay, divided by what? Link 2. Now if we use minus to multiply by everything here, look at what we are going to have. Let's see. That means let me use this side. So I want to put anything. That means our s, okay, our s equals to now into minus the Lambda W function. I'm going to have minus Lambda W function of into 32 okay, divided by what? In what? 2. The minus 1 times 5 plus what? Positive what? 5. Okay, that means I want to put in the way, in the clear where you can see it very clear. So let me remove this, please. Let me remove this, please. That means our x will be equals to, okay, 5 minus the W function of what? Into 32 link 2, okay, divided by what? Link 2. And this is the solution to this particular problem. Can you see how simple and interesting it is? Because this minus multiplied by this minus will affect the Lambda W function, and minus times minus to the minus 5 give us 5, because minus times minus is plus. So this is the solution to this problem. So you can also take the LCM, and also you can understand, you can also take the LCM, the same thing. So what I'm going to do, I know that most calculators, not every calculator that have this function, Lambda W function. So what I'm going to do, you can see on this screen, I'm going to drop the answer on this screen. Okay, I'm going to use my site calculator. Remember, my site calculator, so that I can drop the answer on the screen. So look at this answer on the screen. So that means this answer you are seeing here, if you substitute in place of x, you will have exactly what is what? Have exactly what? 5. So thank you so much for watching. Please, if you find it interesting, don't hesitate. Do it to like, comment, and so share to the long ones or others will learn from it. So thank you so much, and God